Welcome to Octagon Silo Math. So again, we're in silos for concrete, where we want to find out some areas and some volumes. So it's similar to the circular silo, but obviously some things are different because we're dealing with an octagon here. I just noticed I cut off this measurement right here, and that is 150. Okay, so let's continue. As always, let's first have a look at what we see. So we have an octagon shape on the outside, and we have a circular shape on the inside. And the dashed lines here indicate the footing. So the footing isn't as a square around the entire thing, but it's just a bigger octagon. And then here in the cross section, we can see that our footing is 200 mils thick, and our whole wall is 6,000 or 6 meters high. We can also note that each side of our octagon is 6,000 or 6 meters long. Because it is an octagon, it has all the same sides, which is nice. And here we have our thickness of the wall on the flat part. That's important to note at 200. So now that we've kind of familiarized ourselves with what we're looking at, let's have a look at what we need to find out. So the area of the octagon, area of the circle, the area of the wall base. So basically the area of the shape between the octagon and the circle. Then we want to find out some volumes, what's in the wall, what's in the slab, and then the amount of volume of, let's call it water, could fit inside of the silo once it's built. So that last one is not a concrete volume question, but a volume of whatever else. So when we want to find the area of the octagon. So step one. Step one, area of octagon. Well, of course, there's a mathematician way on figuring out the area of an octagon, but that really is not how we carpenters can remember how to do. So we do it differently. First, we need to figure out the area of the square, because our octagon lives inside a square. Imagine this just keeps going, this just keeps going, and it does that on all sides. If you drew this for yourself on a piece of paper, that's how it would come out. And you're basically just chopping off the corners. So the idea of the area of the octagon is that we figure out the area of the square first, then we figure out the area of the triangles, and then we subtract the area of the triangles from the big square, which then leaves us with the octagon. Well, we don't have all the information yet so that we can just say, okay, the square is this side. So I'm going to zoom in here for a moment to change the color of my pen. The triangle that we're trying to figure out is this one right here, and I'll leave it drawn in so it doesn't disappear. What do we know about this triangle, right? If we did this on all four sides, this is what you would come out with to create that square. Well, we know that our octagon side is 6,000, right? So that's 6,000 right here. Can we find out the adjacent side? And because it's an octagon, it means this angle right here is a 45-degree angle. Which means, if you remember hip roof math, the in a triangle that has a 45-degree angle on one side, really it's on both sides, both adjacent sides are the same, right? So if we can figure x out on this side, that is the same as over here. That's important to remember, and that's how we can figure it out. So there are a couple of ways on how to find this. I'll zoom back out. First, I like to draw myself that triangle again, just so I can mark things up. So we have that triangle, 6,000 right here. We have our 45-degree triangle, and we're trying to find out x. So if you remember trigonometry, you can go back to my trig videos as well of SOHCAHTOA. Well, we have the hypotenuse and we're looking for the adjacent side. So we're working within cosine. And if you draw yourself that nifty little triangle, then we can figure out what to do here. If you remember, maybe not, if this is new, you always want to block out what you're trying to find. So we are looking for the adjacent side. So if we block this out, then what we have left is cos, so cosine of the angle that we have, times our hypotenuse. So we have x, or a, equals c times hypotenuse, right? And then if we just pop that in, so cosine of 45 degrees times the hypotenuse, which is 6,000, well, pop that into your calculator just as it is, cos button 45 times 6,000, it should come out with 4243. And that is our adjacent side, or x here. Now, hip roof math, if you remember from our triangle where we worked in the base 1, and if this is our hip rafter, this is 1.414. Well, could we do that math differently or backwards? We could say that 6,000, so our hypotenuse length divided by 1.414, check that out in the calculator. What do you get? It's the same, 4243. So this kind of math works for all triangles with 45 degrees with that 1.414. So you got a couple of ways of figuring that out here. Now that we know what x is, because it's the kind of octagon that is the same on all sides, we also know what it is over here, right? And over here, etc. It's all the same. So now we can actually find the side of a square. I'll call it the square side. And it's 4243 right on the left over here, plus 6,000 plus 4243 on the right, right? So we have 4243 over here, 6,000, and then 4243 over here. And that gets us to a total side length of 14,486. So work along on your calculators. So now that we know the length of a side of our square, can we figure out the area of our square? I say yes, we can. Well, area of a square is length times width, right? Or of a rectangle. So we've got 14, and we're going to turn this into meters now. Otherwise, it gets a little bit too complicated. 14.486 times 14.486. And we come out with 209.844 square meters. And that is our first area of the octagon number here. So 209.844, and we're in area, so square meters. Okay. And I'm totally way too fast. We're not putting that in here. We just figured out the area of the square. That's why you write things down like this, so you don't confuse yourself. And if you do, you can catch yourself. And I purposely leave these things in the videos, just so you know. Cool. So we've got the area of our square. So can we find the areas of our triangles on all four sides and subtract those from our square to then be left with the area of our octagon? I think we can. So area of our triangle. Well, one triangle is base times height divided by 2. Divided by 2 because, well, if we just did base times height, that looks an awful lot like length times width, right? So if we can figure, and then divide it by 2 because the triangle is only half of it. So we can figure out one of them, then we just multiply by 4. because we've got 4 of those. So base times height is the same for us, right? So that's the number that we found up here, the 4243. So again, turning it into meters, we've got 4.243 times 4.243 divided by 2. So that gets us one triangle, 9.002 square meters. Now for 4 triangles, we just multiply by 4. So 9.00, whoopsie, 2 times 4 gets us 36.006 square meters. Okay, so now that we have all of these areas, could we possibly figure out the final area of the octagon? How do we do that? Well, we take the area of the square that we figured out, the 209 up here, minus the area of the triangles. And remember, of all 4 triangles. And then that should get us the area of the octagon. So just popping in numbers, 209.844 meters squared minus 36.002 meters squared. And that leaves us with 173.838. And we're still in square meters because this is still area. Okay, so that is the first one. So I'm going to zoom out. And move this guy down so that we have a little bit more working room. Okay, so we figured out our area of the octagon, and I'm just going to do a check mark because I'm going to end up moving it again and we're going to lose the number anyway. So what's the next one? Area of the circle. Okay, so can we find out what the octagon is straight across? Well, the octagon straight across is what we just figured out, right? The length of the side of our square. And if you think about it, so that's going to be the distance from the outside of the octagon to the outside of the octagon. We can subtract 2 wall thicknesses. And that should give us the diameter of our circle. And with the diameter of a circle, we can figure out the radius. And with that, we can figure out the area. Okay, so first we want to find out the diameter of the circle. So we take our octagon, I'll call it straight across, but it's basically our side of the square length, minus 2 wall thicknesses. Okay, so from here, we just pop in numbers. So our octagon straight across, we just figured that out, is the 14.486 meters, right? So that's one length plus 2 of our triangles, minus 2 times the 0.2 meter wall thickness. Punching that into the calculator. 14.086, right? Could have also done that without the calculator. So that's the diameter, right? So that's all the way across. So the radius for our circle is half of that, right? So 14.086 divided by 2 gets us 7.043. That is the radius of our circle. Now, with that, can we find the area of our circle? I say we can. So its area, so pi r squared. And again, just popping in the numbers. So pi times r that we just figured out, 7.043 squared, gets us the area of our circle. 155.835 meters squared, right? We're still in area. There's a second number, area of the circle. Done. Awesome. Next, we want to find out the area. I'll make a nice line across here. The area of our wall base. Well, let's first figure out what the heck that is. So the wall base, our concrete is going to be everywhere inside the octagon and outside of our circle. That is our wall base, right? That's where our wall here sits. So all we need to do is take the area of our octagon minus the area of our circle, right? We take the big minus the small, which gets us what's left in the middle. So area of our octagon, already figured that out, 173.838 meters squared was still an area, minus the area of the circle, just figured that out, 155.835 meters squared. And that gets us to 18.003 meters squared. That is the area of our wall base. Easy peasy. Very nice. I'm gonna move this down one more time. It's the only downside to doing it on a drawing pad. We'll re-put in our check marks. We just did all of these. Okay, so next one, concrete in the wall. So now we're looking at the volume of our wall. Well, how do we do that? Well, usually length times width times height. Well, length times width, that sounds awfully familiar to something related to area, and then times our height, which means the area of our wall base that we just figured out times the height of our wall. And that is given to us right here with the 6,000. And again, of course, we're going to turn it into meters. So area of the wall base, just figured out 18.003 meters squared times our height in meters, which is 6. Punching that into the calculator gets us to 108.018 cubic meters of concrete. Bam. Did that one. Awesome. Okay, so now concrete in the slab. That one is a little bit more involved, but really it's the same as we did before with a couple of tricks. So this was the number that I accidentally cut off. Sorry about that. So what do we first need to figure out? So we are looking at the slab and it sticks out by an extra 150 mils past our walls, right? That is the dashed line. So this right here in between is 150 from here to here on all sides, of course. First, we want to find out what the square of our footing is. Well, can we figure that out? If it's 150 up there, obviously it's 150 down here, right? So if we can reimagine our square and just making it a little bit bigger, all we need to add is the 150 on each side, right? So 300 mils total. So first is the square of the footing. So we've got our original side of 14.486 that we already figured out, meters, and we're adding plus 0.3. That's 150 mils on each side. And that gets us the new side of our square of 14.786. So now, check this out. I'm going to draw these in. I'll draw this in blue. These are the triangles just like before that we're trying to find out. Now, there's a really cool rule in octagons that half the diagonal of a square, of this square that the octagon is in, equals to one octagon side plus one of the triangles. Okay, I'll write that out. So half, yeah, we'll keep it blue. Half the diagonal of the square equals one octagon side plus one triangle side. I encourage you to draw yourself a square with actual square measurements and then take a compass, set it to the corner, uh, draw yourself the lines across to find the very center of your circle or of your square. And then this measurement right here, if you pop that in with your compass and you rotate it around, is the same as this one right here, from here to here. And that is just a really, really cool geometric trick of octagons. Okay, so drawing in the diagonals of your whole square, finding the center, popping on your compass from the corner all the way to the center, then rotating it around, and you're going to come out perfectly at that corner. This one right here. So we can use that to our advantage. First, we need to find the diagonal of our square. So diagonal of square, how do we find that? A squared plus B squared equals C squared. So we've got 14.786 as our sides squared, right? We just figured that out up there, plus 14.786 squared. Take the square root, which gets us the full diagonal of 20.911. Well, half the diagonal, we just divide by 2, right? So 20.911 divided by 2 is 10.455. So we know that from the corner to that first edge up here, this is 10.55. 10.455, sorry. So right here, 10.455 from here to here. So if you look at that picture, can we figure out what our triangle side is? I think we can, because we know what our full width across is, right? Our full square side, which is the 14.786. If we subtract our 10.455, we come out with our triangle sides. And then from there, we can figure out our triangles again, etc. So our triangle side equals to our whole square side, so the 14.786 minus our magical 10.455. And that leaves us with 4.331. So I'll take that away and I'll pop in 4.331. And if that side of the triangle is that, then this side is the same, 4.331. From here, can we figure out the area of the triangle? Just like before, of course, it's our base times height divided by 2. And we need to multiply it by 4 because we have 1, 2, 3, 4 triangles. Right? So we've got 4.331 times 4.331 divided by 2. That gets us to 9.379. And always do the math with me. So we're in meters squared now. We're in an area, and we need 4 of them. So let's just continue with times 4, gets us to 37.515 square meters. And it's not that much more than what we had before, right? Which was 36 point something, because the octagon itself is only slightly bit bigger than what we had before. So that's why the numbers are fairly similar. Okay, so now can we actually find the area? I'll zoom out a bit to get a little bit more space. Can we find the area of our octagon footing? Let's see. Well, do we have the square? Have we figured that out? We haven't yet, so we're going to have to pop that in here. But we find the area of our square minus the area of our triangles, and that'll get us the area of our octagon footing. Right? So just to showcase, we take the area of our square, we'll just pop that in there, minus our triangles, and that will leave us with our octagon of the footing. So the square, we still need to pop that in here. So that was the 14.786, right? Each side times 14.786 minus our triangles, and that was 37.515. Doing that math, punching it into your calculator. So we've got 218.626 minus still 37.515. I like to just do one step at a time when I show these. And we end up with 181.111 square meters for our octagon area of the footing. Now, can we turn this whole thing and use it to find out the volume of our octagon, of our slab? That's the whole thing of why we're doing this, right? So this is still that number. So we have the area of our octagon footing. Great. And any volume, now we can find out for our slab is area times thickness, right? So the area of the slab that we just figured out times our thickness, and that will get us the volume. Area we just figured out, so 181.111 meters squared times our thickness of 0.2 gets us 36.222 cubic meters of concrete. And at the end, if there is a question to say, okay, how much concrete do we need to order in total, add them all up, and then if it says, okay, round up to the next meter or whatever, then you do that rounding. Great, so concrete of the slab, finally did it. So that one is a little bit more extensive, but you just do the same thing over and over as we did before, right? So finding your outside square and knowing, and that is just the thing to know, that half the diagonal of the square that your octagon lives in equals the distance of one octagon side plus the triangle. Once we figured that out, we took our total square length minus our fresh magical number, and that leaves us with the triangle side. Now we figured out one of the triangle sides, which means we can figure out the area for each triangle. We multiplied that by 4 so that we could get the areas of all the triangles. And then to find the actual area of our octagon footing, we took the area of our square minus the area of our triangles. And that left us with the entire area from the outside of the footing. And from that picture, it shows us that it goes everywhere. And then finally, we could take the area that we just figured out of our slab and multiply by the thickness, and that gets us the volume. Great. Now we just have one left, the volume of the silo. And that one is not quite as extensive. So what we're looking at is the volume of goods that we could stick inside the silo once it's built. So everything inside the circle. For that, we need the area of the circle, which we found out way above, so that should be in your notes, times the height. The area of the circles that we figured out before was 155.835 square meters. And our height is 6,000 on the inside, so times 6. And that gets us to 935.01 cubic meters. If someone said turn it into liters, we know that 1 cubic meter has 1,000 liters in it, so you would multiply by 1,000 to get that. So that gets us the check mark for the last one. So you can see that it kind of just, we have to do everything twice for the area and the volume of our octagon, and then again for the footing. So just one step at a time, and just keeping really good track of what it is you're trying to figure out. What is the main thing you're trying to find out, and what are the sub steps on how to get there? If you keep everything nice and organized, and you put in your equations every time and what it is that you're doing, that'll just help you in the long run of being able to do it a little bit better and easier and with more understanding. So I hope that helps.